Our daily lives are governed by human-sized measurements: a mile to the grocery store, 1,000 miles across a continent. But once you leave the atmosphere, those earthly increments are replaced by light minutes and millions of miles of empty space. To figure out where we are, we have to start at the absolute baseline. This planet is the first line of our cosmic address. Centuries ago, early astronomers used Kepler's laws to map out the solar system using orbital ratios. They knew exactly how far the planets were relative to one another, but they lacked a way to calculate the actual physical distance of the system in miles or kilometers. That changed when observers tracked rare planetary alignments. By measuring the exact time it took Venus to cross in front of the Sun from different points on Earth, they could finally calculate the astronomical unit, the nearly 93 million mile gap between the Earth and the Sun. Pinning down that local distance was the necessary first step. It gave us the scale required to move beyond our immediate backyard and begin mapping our position relative to the rest of the galaxy. Past the planets, the Sun is constantly blowing a stream of charged particles into the void. This solar wind carves out a protective bubble around our entire system, called the heliosphere. Eventually, outward solar pressure meets the inward pressure of cosmic rays. Where these forces balance is the heliopause. Moving through the Milky Way stretches this bubble into a teardrop shape, trailing 123 to 140 astronomical units away. Outside that boundary lies the interstellar medium. It is a thin collection of gas and dust cast off by other stars, filling the gaps between systems. Crossing through that invisible wall of pressure is the true threshold. It is the point where the environment of the Sun ends and the wider galaxy begins. Pulling back even further, our entire solar system shrinks to a single point of light, embedded deep within the Orion arm of the Milky Way. The Milky Way is a spiral structure spanning roughly 100,000 light-years, housing hundreds of billions of stars and planets. From here, the Sun is no longer the center of the world. It becomes one faint dot among billions, adrift in the vast rotating disk of the galaxy. The galaxy itself is in motion, acting as a massive vehicle that carries our star along as it drifts towards its next cosmic destination. Moving out 10 million light-years, we reach the Local Group. This is our immediate galactic neighborhood. Within this pocket of space, two massive gravitational anchors dominate the group, the Milky Way and our neighbor, Andromeda. These two giants are surrounded by dozens of much smaller satellite galaxies orbiting tightly around them. One of the most prominent is the Large Magellanic Cloud, a dwarf irregular galaxy caught in the Milky Way's gravitational pull. In total, there are over 85 known galaxies in the Local Group. They are all tied together by gravity, pulling on each other and gradually drawing closer over billions of years. We are not floating in isolation. We are part of an interacting family of galaxies, destined to eventually merge into a single structure. Expanding the view to a diameter of 147 million light-years brings us to the next line of the address, the Virgo Supercluster. Here, our entire Local Group is caught in an orbit revolving around the densely packed Virgo cluster, alongside more than 47,000 other galaxies. At this scale, whole families of galaxies lose their individual identities. They become nothing more than single data points in a much larger architectural framework. On the largest scales of the universe, superclusters connect into glowing filaments, separated by dark supervoids. This is the cosmic web. Most cosmological models assume the universe is homogeneous, meaning matter should be distributed smoothly on the largest scales. However, structures like the Sloan Great Wall are so large, spanning over 1 billion light-years, that they challenge this principle, existing as massive clumps where the universe was supposed to be uniform. This logarithmic data map displays the current limit of human observation. It compresses 200,000 individual galaxies, radiating outward from our central point in space. As we look toward the edges of this map, the galaxies appear redder. Because the universe is expanding, the light from these distant objects is stretched into longer, redder wavelengths before it reaches our telescopes. This map of thousands of points constitutes our complete cosmic address. While these distances are far outside our daily experience, they provide the specific coordinates required to trace a path through the dark, back to Earth.